so after seeing some information about the Postgres JDBC driver and so on, just a few tips more. First of all, the URL, if you remember, the URL looks like this, so where you specify the connection to the database and so on. It also supports some parameters. Here you see the question mark options, and then there you have some parameters. Like, for example, whether you want to use SSL, the log level that you want to use, some interesting options to log and close connections, and some timeouts. There's a definitely wider list of parameters that you can use, and I recall you to go to the official documentation to check for them. So there's several that you can use. But important that here they are, and they're there for you to use. A few notes about SSL. Some people experience some problems when using SSL connections to Postgres from the JDBC driver. And this is because typically most Postgres installations that run with SSL enabled don't have a proper security certificate. I mean, typically they use a self-signed certificate, which is a bad practice if you want to use SSL. But typical programs like PGConfRu do not validate the certificate chain. However, Java does. And since the JDBC driver relies on Java management of SSL certificates, you will experience an error and will not connect, basically. So, you know how these things work with the certificates, that they need to be signed by a valid certificate authority. So, there's three ways of fixing this. The first and most obvious one is to use certificates signed by an authorized certificate authority, in which case it will work perfectly, no problem. Second option, if you still want to use your own certificates or signed certificates by a certificate authority which is not a well-known certificate authority, then you could add this certificate authority to the Java key store. The key store is the mechanism Java uses to manage SSL certificates, and you could add that. That is something specific to Java, but it's also documented here, how to add a certificate to the Java key store. And the third method, which is something you should not use, is highly not recommended, but everybody uses, which is to pass an null parameter to the URL, which says basically use the non-validating factory, and that will not validate their certificate chain. But that's a really bad practice, because you will do this on test environments, and it will work, and suddenly then you're using Docker, and you ship that Docker to production, and then you're not validating this certificates in production, and then bad things may happen. So don't do that. Just add the certificate to the key store, which is a very simple process anyway, and you're good to go. Don't be lazy, in other words. But this is something that creates some problems, and it's interesting to know. What else? Already mentioned that it's good practice to use prepared statements. I had some question in the break that whether prepared statements create server prepared statements. The answer is not necessarily. So prepared statements sound like a lot like some database functionality, which is called a prepared statement, right? Indeed, it's exactly the same words. So a server prepared statement is a mean for the database to plan a query ahead of time based on the query string, which is going to be the same. Maybe the parameters may change. And this might be good or bad for performance. There's many edge cases. But typically, if the data cardinality estimation does not change significantly from parameter to parameter, or the query has no parameters, planning the query ahead once yields some benefits in terms of performance, because the query planner needs not to pre-plan the query all the time. So you save some time in query parsing and query planning. And so if you use a prepared statement in JDBC driver, that may not turn into a server-side prepared statement directly. There's a threshold, and by default it's 5. You can change also with another parameter in this URL. After which, if you have executed that same query several times, then it will create a server-side prepared statement. Only above this prepared threshold, which by default is 5. So this is something that you may want to know, because sometimes prepared statements, server-side prepared statements are good, most of the time. Sometimes they are not. In which cases they are not? In cases where you, for example, prepare a query for a value that may have whatever cardinality, let's say a low cardinality, and then an index is going to be used because it's low cardinality, and it's easy to pick it in an index because it's going to return a few number of rows. Now, if you pass that query with another parameter, and that other parameter has a lot of cardinality, in other words, it will return a lot of rows, then it might be more beneficial to plus X kind of the table rather than using the index, if the index will be used. So also Postgres has a method itself to invalidate prepared states, server-side prepared statements, and switch to generic ones if it detects that these cardinality changes may happen. The driver also has some hash about the statements and may invalidate plans, but typically happens, and that was the question, if there is some facts that may invalidate the prepared statement itself, like for example a DDL change. But this is a very complex topic. So there's many things to discuss here, and there's, by the way, one talk about JDBC and Java done by Vladimir. Sorry, I don't know how to pronounce the name. Sorry if I think off. That explains in more detail these topics. I would recommend you to Google that. Very interesting. But for here, at least to know that JDBC prepared statement is not exactly the same thing as a server-side prepared statement. It will match after we reach this threshold of executing the query so many times.
Is this number of times is created for single prepared statement object or for total for connection?
It is computed per connection.
Per connection,
I think. Yeah. Okay. Few notes about concurrency. The connection object itself, it is something that is thread safe, so you can pass it along to other threads. That's not a problem. But bear in mind that Postgres has one process per connection, and thus there is no explicit concurrency available for you. So within a single connection, you can only throw a query at it. I was talking about before about asynchronous operation, but asynchronous means that you can throw many queries at it and then wait for the results will come in order. But you cannot throw two queries in parallel and wait for two parallel results. There's also parallel query execution in Postgres since 9.6, but that's a different story. That's not explicit to you, that's internal to Postgres. So for you to know you only have one connection, you can only do one thing at a time with that connection, although the connection object is something you can share across threads. And of course, you may want to use connection pooling. There are several connection poolers in Java, and I will give some notes today about some of them. So talking about, yeah.
Have you used some connection pools? Which connection pools you use in your application? Okay.
Leave the question unanswered for the next 2 or 3 minutes. The question is which connection poolers I'm using. I'm going to tell you right now in a few slides. Okay? So basically, how to use a connection pooler is very simple. Connection pooler could be, for example, generic. You just add the Postgres driver, the JDBC driver to the connection pooler, and you basically set the data source. Typically asks you for the data source class name, and you put this data source, and then define out this properties. This is pretty useful stuff, nothing specific. So let me jump over that. Okay, so it's not just right there. Sorry about that. Okay, so I'll answer the question. Which connection pooler I would use? Postgres side or application side? Application side, I would say Hickory connection pooler. Hickory. This one. But why?
What were reasons for choose the Hickory instead of other connection pools?
So, hold on, let me just bring this first here.
I know it.
Yeah, but
We know.
What were reasons for choose the Hickory instead of maybe Apache, maybe
C3PO.
TTPO, for
Zero.
example, yes.
Okay, first of all, I just wanted to show the screen for everybody. So why would I choose Hickory? First of all, because it's very flexible, and our own performance measurements have resulted that it's fastest by a wide margin compared to all the connection poolers. It's lightweight, and it's the way it's done, what we have read about it, the principles that it applies to the development look very appealing for us, and it worked well. It has worked well for us so far. We've been using Hickory for many years.
Can you tell us the number of value of increase in performance when you're using Hickory connection pools instead of some other TTPO, for example?
No, I don't have those numbers here. I would need to check. But I mean, we made this decision several years ago. We made some benchmarks back then. I could look for those benchmarks probably, but I don't know my numbers.
How to see the performance test, performance comparison between the Hickory and our connection pool in real environments, in real tasks, only in specific tasks with many change connections, create new connections, but it's not very common cases. So there's specific cases. But in common cases, I think it's now different between TTPO and Hickory.
Authors of Hickory connection pool control that
Hickory connection pool is faster more than 100 times in some cases.
Yeah, that is true. What he was saying, no? That Hickory made many benchmarks by the time, but those benchmarks were very non-real use cases, like creating connections like really fast, but not doing anything with them. And in that case, it was very fast. But that was not the most usual case, and of course you should not rely on those.
This is very. And second, my question is about connection pool. Do you use PG bouncer on the server?
Yes. So, yeah. So, I have some slides precisely about Hickory, and one of the reasons I like Hickory, and then I'm gonna jump over that. But
Let's talk about that now. And also combine it with another tool called Flexipool. So I don't know if you have seen it. Flexipool. Yeah, that's So this is Flexipool. So this is for us at least, this is a great combination. Hickory Connection Pooler and Flexipool. One of the things that I like about Hickory Connection Pooler is that you can specify metrics with a library of separate metrics, and then it collects metrics about the connection pooler itself, which you can later on inspect or use with JMX, for example, to connect to and expose those metrics over JMX, and then check how the connection pooler is doing. Flexipool adds on top of this with its own metrics, and it's also able to. Flexipool is just a wrapper over any connection pooler. It's a very cool, simple tool that again grabs other existing connection poolers, provides more metrics about them, and even allows to manage them and resize them dynamically based on some smart algorithms that it has. So this combination is pretty cool. And I have some on the code, which the code, what is this? Yeah. So the code which is here, this is the code for this demo for today. You can find some example, which I'll just show now because I jumped over this session, about Flexipool and Hickory. Oh, it's here. again, so they're very good combined, and I'll just very quickly show the code about how to use them combined. And again, you can check it on the GitHub page of this tutorial to see the code in more detail. So this is an example of the more or less previous examples, but in this case using Hickory and FlexiPool. So it's Hickory connection pooler, and then I wrap it on top of FlexiPool. And in this case, this is a program that just runs many queries. Basically, it's going to run 50,000 jobs. Put the jobs and then execute the service, and then execute all the jobs. The queries results are going to be later on discarded. But then what I do is generate a metrics name called Java PGPool, and I'm going to record the operations on this. The queries are not being printed, and then I'll print the statistics each 2 seconds. So let me just run this to show you an example of what this combination can do. Again, this code is on GitHub. You can check it out anytime. So right now I'm doing a lot of queries to the database. 50,000. It's not a lot anyway. And each 2 seconds, this is printing the statistics about the connection pooling. And as you can already see, it's about to finish. Okay. So here we have some statistics that we can run very easily with Hickory and FlexiPool. And you can see, like, for example, the count of connections, the rate of the connections, the time used on these connections. There's also more statistics. This is about the wait events per se, but this is the usage, like how many real physical connections were used, how many they were reused, and so some parameters that you can get. And this is just one example of exposing these metrics, but they can also be exposed over JMX, or you can just collect them or do whatever you want with them.
You use 50,000
jobs
to repeat. You repeat some code 50,000 times.
Yes.
This is. I think that this is not correct test because Java translate code to machine dependence code. If you use server Java, translate it after 10,000 runs and client, as I remember, once.
Okay, so let me.
There is some mistake
I think it's a demonstration of FlexiPool.
Yes.
Functionality, but not about performance.
Yeah, exactly. A couple of things there. Thank you for that. So let me rephrase the question. Correct me if I'm wrong, but basically the question is: so Java does some optimizations, Java compiler, and here you're basically doing 50,000 times something, then you're discarding the results of the query. So Java may be optimizing that away, and this test might be wrong. The answer is, first of all, this is not a performance test. This is just to show the capabilities of FlexiPool. Second, as you can see from the numbers, no result has been discarded. The pool here is saying that it has the connections have been reused 48,000 times. The remaining, those are the connections that have been effectively really created, which appears to be around 50,000. It will be, of course, exactly 50,000. So it seems to be Java did not optimize this away. The reality is that it's much more deeper when Java is able to explicitly optimize away those kind of things. Second, I'm not doing a for loop here. I'm just creating jobs, runnables,
putting those runnables through a queue of completable futures. And then I'm executing all those with a completable future, an executor service, which means that Java doesn't know that those 50,000 tasks are similar or not. So it cannot optimize them away. And even more, Java can optimize things away when Java knows effectively what's going to happen. But here, I'm just throwing a query to the database. Even though I'm later on discarding the results, and Java may know that I'm discarding the results, Java doesn't know whether that has some side effect on the database. So cannot optimize away that. I'm calling an external service, and Java cannot optimize that away. So yes, thank you for that comment. If this would be a performance benchmark, I would have done it differently. Indeed, I would have been using JMH, but it's not. It was just the way, I just wanted to show, hey, do many things with the database and print some statistics, and you'll see how this combination of FlexiPool and Hickory connection pooler with metrics enabled can expose this statistics real time to you or via JMX or whatever you want. And this code you can check on GitHub because it's part of this tutorial. Okay, so that was another thing. May I borrow some water now for you? Oh, thank you. No, even better. Yeah, if you can, I appreciate it.
Okay. I didn't drink like this.
It's okay. I appreciate it. Okay, so that was another example that I wanted to give you about.
No water left. So this is the last one. No, take. I'm okay.
I'm good so far. Thanks. Oh, on the last question, which was very interesting. So I said, okay, yes, Hickory connection pooler, one option at the Java side. But what about having another pooler in front of Postgres? That is absolutely, absolutely, absolutely always yes. Yes, you want, and yes, the answer is PGBouncer. The reason why, there is no significantly added latency. And if someone can prove that that latency is too much, please let me know. I'm interested in knowing the use case. And if it's not, Postgres should always be front-end by a connection pooler like PGBouncer, because it creates independence. It will not throw away connections, reject connections when some limits are passed. It is very lightweight and is very fast. Now, on the application side, you may use connection poolers, and that's not a big deal. I've seen application architectures where there are 3 levels of connection poolers. One in front of Postgres database, one at the application side, and middleware connection poolers to create independence and redundancy channels and so on. And that's not a problem. Even that combined with HA proxies in the middle. So 4 layers of basically TCP/Postgres connection pooling, and that's not a problem. And indeed, it's a very recommended approach. Okay, so this is about connection poolers. And this is no longer working. Why not? I don't know. Okay. Another short demo I would like to make, but since we're running out of time and I'll have a lot of things to say, I'll be just quickly running over it. There's a really significant addition to Postgres driver version 42, which is support for logical decoding. Logical decoding, it is a completely whole interesting topic. How many of you know what logical decoding in Postgres is? 1. Okay, wow. If you want to know more about logical decoding, Google my name and logical decoding in YouTube, for example. And as a bonus point, you can see a talk that I did a couple of years ago about logical decoding in the conference at Dallas. And as a bonus point, you'll see me doing a talk with a Texan hat, because it was in Dallas. So anyway, short description of logical decoding is a Postgres name of CDC, or change data capture, which is basically another way of saying that the database can emit via a special channel the changes that happen to the database in a format which is, let's say, idempotent. In other words, whenever I do an insert, a delete, or a delete to the database, by a separate channel, I can get this was inserted, this was deleted, this was updated. Even if I say update table A equal A plus 1, and that results in hundreds of rows updated. I'll get, by the other channel, hundreds of update A equals to 7, update A equals to 9, update A equals to 101, where ID was blah, blah, blah. And so it is a way of extracting from a logical perspective, in other words, independent from architecture, from CPU, from Postgres version, all the changes that happen to the database. In such a way that if I take those changes out of the database and put into something else, which could be an application, could be a Java application that processes in a stream fashion to try to detect fraud, for example, in real time, or I just want to represent this state of the database in a separate system by just executing those commands in a separate system, that is very normal, and this is done at many places, and that is what logical decoding enables. So basically, it is a channel to extract all the changes, so selects will produce nothing, but inserts, deletes, and updates will produce things, and I could consume them. The problem with logical decoding in Postgres is that it goes through the replication subprotocol. So Postgres protocol has one part which is the replication subprotocol. And this replication protocol is the one that is used for the logical decoding to take place. The problem is JDBC spec talks nothing about logical decoding. And so in order to implement logical decoding, new stuff needed to be added to the Postgres driver, specifically support for the replication protocol, because there was no support for the replication protocol on the JDBC driver. But it was added, and it was finally, the patch has been discussed for more than a year, and it was finally added to Postgres version 42. So let me do a quick demo of that too, because I think it's interesting. It's going to be yeah. Okay, so here you have another example. This is part of the code that is on GitHub. You can check it out anytime. There are some parameters that you need to set up for Postgres before you can use logical decoding. I won't get into those details. The code is a little bit complex, so the current implementation is a little bit low level, but still, you can do it. And so basically, in this case, you need to, for use logical decoding, you need to create something called a logical slot. This is a class that we have created for this example. Tim, what are you doing? Okay. This is the logical decoding manager, which is a class that uses the low-level interface provided by the driver. It talks about some concepts like the log sequence number, which are numbers associated with the process of logical decoding, sets the properties to the connection, creates the slot, which is this way of managing the state of the logical decoding process in Postgres. This is something I won't get into the details. If you're interested, I recommend you to search for logical decoding presentations about Postgres. There are quite a few. And the drop the replication slot. So there's a lot of infrastructure done there. The most important method is this, which is the method that will receive these changes. These changes are received as bytes because they could come in any format. When you use logical decoding, you have to say, I want this output to come in this given format. It's like a plugin, and you can install new plugins. And then this is the receiving of the bytes and processing of this format, and instructing Postgres to say, I have already consumed this, so advance the pointer. Anyway, not getting into the detail of this, but interesting here, things to notice. There is another connection used. So one connection is used for queries, one connection is used for logical decoding. So in this example, in this code, what I'm going to do is I'm going to open these two channels. The logical decoding one, I'm going to be listening for changes to the database, and I'm just going to print them to the screen. And a separate connection, which is going to be a normal connection, and then I'm going to do some insert of data. And we'll see that the changes that are due to the database through the first channel will appear on the second channel. So the code is here. Again, I'm not going to get into the details of it, but basically here I'm just going to print the information that comes from the channel, and then here I'm going to perform some operations. So let me just run the code for you to see what happens. Okay. That was from before, and okay. Okay, happy with that? Let's back to this one. Okay, so this is what I'm printing here is the information that is received over this logical decoding channel. So of course you need to trust me that this is not print from anywhere else. There's two connections, one that performs some insertions and then one that performs some deletions. And what I get in the second channel, which is the logical decoding, where it's listening to, and this is pushed to by the database, so there's no pooling process. So I'm just listening on this second connection, and the database tells me, hey, it's been this inserts, hey, it's been this deletes, and then I receive that information, decode it, and print it away here in the console. And as you can see, this information got inserted or deleted to the database. So I just wanted to highlight this. This has been added to the new driver. You can check this code to see how it works. It's a little bit low level, but you can extract these logical changes from the database, and I think this is very cool functionality right now. Any question?
If I'm not mistaken, at logical channel, we can see not only data flow, but some comments, maybe for consistency between logical apply and driver.
You mean DDL changes?
Not the DDL changes, but some kind of command used for replication protocol, such as wait last listen applied and so on.
Yeah. So there's indeed some information that comes with the logical decoding process. So basically, when the logical decoding process works, it has a position, an LSN, log sequence number, that identifies the stream. The stream is a linear thing. It goes from time zero to time present. And when you ask for logical decoding, you create slot, which is basically a window of those changes. And that window starts, let's say, here. And then as long as you consume the stream of changes, you make this pointer to advance until the present time. And so this information, like where is the log sequence number at right now, it's something that also comes indeed with the channel. So yes, there's some meta information associated with it. But as of today, there's no DDL that comes with logical decoding. So only changes to data and metadata about those changes. I think that was first.
Logical decoding is cool, but can you tell us most common use cases in Java applications for these technologies?
Yeah, I mean, absolutely. For example, there's many places where people want to do some real-time processing of data changes to the database. Imagine, I've seen many examples of companies detecting fraud. Companies detecting fraud, it's something that works on changes to the database. So whenever there's someone buys something, that means probably an insert to the database or several or whatever. If then you connect a Java program that will consume this stream, and using a stream technique like either Java 8 streams or akka or Spark, whatever you want. You get this information, and maybe you can keep in memory some small state. And then with that state and the current transaction, you determine whether that was fraud or not. If it was fraud, you signal it, and that's it. If not, you're done. But if you would just be querying a huge database just for that record all the time that happens, that would be very, very expensive for the database. So stream processing, it is one of these uses where Java, I'm sure, plays a significant role in processing logical decoding.
In SQL server, CDC mostly widely used in data warehousing operation to...
Yeah, so that's a different topic. So what CDC is used for? And many people use CDC for many things, like, for example, for online data processing, for data consolidation to data warehouses, or database materialization, that's called sometimes also, to reproduce the state to a different database, and those programs could be written in Java. I see absolutely no reason why not. That was the same question, or that's a new one, or you had? Okay, okay. Anything else? Okay, so let's continue. About the other driver that I mentioned, the PGJDBC next generation, I would just say, give it a try. There's been a last version recently released. I won't speak much because I want to move forward. There's some characteristics that are interesting from this driver. I like the idea. The only change that you need to use this driver is to change the URL. Instead of JDBC:PostgreSQL, it is JDBC:PGSQL. Other than that, everything should work equally well. We did some performance between both drivers with not this latest version, but the version that was before with PGJDBC NG. And in this very limited test, it performed worse than official JDBC driver, which has significantly improved performance in the last couple of years. But your mileage may vary. Please test it on your own. So some quick notes on these other connection methods that I said about. The process builder, this hackish way of launching an external process like PSQL to execute commands to the database. It works. It, of course, has some problems, but it works. And I can show you very briefly the code. It's also here, so if you want to know how this works, you can access it. Let me just open. Again, all this is inside the source code. For example, in order for you to understand why we use this once, is several years ago we did a project which was called BTP. BTP means Billion Tables Project. And it was a project to create a billion, American billion, so 1,000 million tables inside Postgres. What for? There was no purpose. It was just to test whether Postgres was able to create 1,000 million tables. The tables were empty, by the way, but it was a test. And yeah, we got some beers because of doing that. It was a very interesting thing. You can Google for that if you want to. There's a specific presentation about this project, the Billion Tables Project, BTP. Now, it turned out that creating these tables over JDBC was very slow. And it was also not possible to create this concurrently in an easy way. So we turned out the solution to the process builder to which basically turns out to, you will call PSQL and with process builder, it's very easy to manage the life cycle of this external process and to connect the input stream or output stream on the error output stream of the external process from Java. And it's very cool. So basically, I instantiate this process builder here. What I'm going to run is psql-e and then the coninfo. The coninfo is just the URL. And then I'll say, hey, take the output and redirect to my process, which means I'll get the output in the standard output, and the error output, I'll put it to a file. I can do whatever I want. And then I start this external process. And now, since I didn't change the output, I can write to this process. How I write, it's very simple. I get the output stream from this process, and then I create a buffered writer. So now I write to it, and I say begin, and then I have a method here that basically execute create tables and drop tables in batches of 1,000, I think, and then do a commit. So here I just basically drop tables in case they were exist, and then I create the tables, and then I commit, and then at the end I wait for the external process to finish, and then when it finishes, I just print the count. So, you know, and it should work. For example, if I run this, it may take a little bit, but you know, I'm using it first to drop 10,000 tables, and then to create 10,000 tables inside Postgres. And all this was done without the JDBC driver, just calling PSQL and issuing the commands. Like if you would just say PSQL and type these commands, of course, very fast. That's it. Nothing fancy, but just for you to know that it exists, and there are some valid use cases for this, which are probably very tiny use cases, but it's there.
If you are dropping all the tables in schema, why not use drop schema?
Because that code was taken from the real program, and that real program needed to kind of, in some small circumstances, manually roll back a batch of operations. So I wanted to delete only, and the code was borrowed from there. But of course, yes, if you just drop the schema, it will drop the objects. By the way, it's very funny. Let me just. It's the. Just a moment, I need to check which database this is on. Process builder. Where are you? Oh, world, okay. So, okay, so here's the schema BTP. If I do that, drop schema BTP.
I can hold it for you.
Thank you. I think that's enough. Basically, it doesn't. You cannot see all the drops. It says there's many more. Just check the logs. So yes, the answer is yes. Of course, I can do that.